Hello, my name is Gabe Rueda, and this is my Lab 3 video report for Physics 1. This lab introduces the concepts of gravity modeled on GlowScript. The general concepts at play are the force of gravity and Newton's second law. Both of the starter codes have initial values, the first one having random initial values and the second one having preset initial values. And they both require coding in order to find specific values of mass and velocity derived from the values of FNet, orbit, mass, and others. All of this was done on GlowScript from starter code supplied in the lab introduction and to-do. For the first model, the question is asking to find the mass of a black hole with randomized values for the FNet, with a relatively small bound for the FNet, so that any randomized values you get would be roughly similar. And then you would have to use the FNet value at each point and solve for the mass through the code and have the code display the masses at each instantaneous point and what they could be. From those points, I received about 547, and those values would then have to be averaged to find the mass of the black hole. And that's what the question is asking. And the data for here, 537 values were given by the GlowScript, and the average of those values for me was 1.20836 times 10 to the 34 kilograms. The second model had initial values given as the mass of the Earth and the mass of the Moon, and the idea was to find the initial velocity from launch off the Moon of a spaceship and what it would need to be in order for it to make a figure 8 orbit around both the Moon and the planet in the center, the star in the center. The planet's mass and ship's mass are given, and the Moon's mass, and it would require trial and error in order to find the right velocity that allows for this type of figure 8 orbit after 700 hours. The data was then derived to be 2,700 meters per second, which is required in both the X and the Y directions in order to successfully pull off a figure 8 orbit for this spaceship. The magnitude or the speed of this velocity is 38,183 meters per second. This speed allows for a figure 8 orbital motion. The rate of change is different. The rate of change momentum is different from the net force because the net force is the cause and the rate of change of the momentum is the effect, meaning they are equal to the same thing. They are the same number. However, the rate of change of momentum is something we can see, whereas net force is invisible and we cannot see it. However, they are essentially the same thing. Just one is measurable and one can be derived because it's the same thing. And this goes the exact same for the parallel and perpendicular components, because the parallel component is the direction of motion and perpendicular is contrary to it and is what the perpendicular change in movement and momentum is. And then because everything would be in orbit in this system that it's asking about, including the black hole, star, planet, moon, and spaceship, they would all have roughly equal accelerations The mass would be different, but the distance would cancel that out, and so they'd all kind of have the same effect. And in conclusion, the lab shows that through code, the relationship between force, velocity, masses, and size. In the real world, especially in astrophysics, things like satellites and spaceships that require gravity and require very precise calculations can be modeled in a very similar way.